All right, guys. We're going to go on and get started with 7.42. 7.42. So we're finishing up chapter 7 or section 7.4 today, not the chapter. So what we've been doing in 7.4 is addition, subtraction. We've been adding and subtracting rational expressions. Now, before we get started on the lesson today, are there any questions over the homework? Or any of the homework assignment problems that y'all want to see? Now, what we're looking at today is complex fractions. Now, we consider them to be complex fractions because we're going to have fractions in the numerator and denominator of the rational expression. So we're going to have fractions in fractions, which you covered in Algebra 1 in that we can't have 7/3 over 1/3. We just can't have these two fractions in the fraction because it doesn't work. We don't like having fractions in fractions. Now, luckily for us here, 7/3 over 1/3. If we had this here, I can just take the calculator, say fraction 7/3 over 1/3, and let it do it for us. Because it's just numbers, it can simplify it nicely there. Now, here we're going to have variables, and unfortunately both the calculators we have to have a value for the variable, so it won't do it for us. But there's two methods that we can do this by. Method 1 and method 2. I have a feeling, I'm not going to say which, but I know which method that y'all are going to prefer and which one that's going to be left behind and forgotten, just like Blockbuster. So we're going to look at this here. Now, we're going to do this problem by both methods. I'm going to do it by the first method first, and then we'll do the second method second. Now, the first method, what we do is we add or subtract the fractions in the numerator and denominator. We simplify them first and then divide. Now, for this problem here, the numerator is already as simplified as it gets. 5 over x plus 4. Now, if you want to, you can just watch this here and then actually write down method 2, because I have a feeling that's going to be the method that you're going to use anyways. Now, the denominator, 1 over x plus 4. X plus 4 is as simplified as it gets, 2 over x. Those denominators are as simplified as they get. But we want to be able to add them together. And to be able to add them together, we need the denominators to be the same. So we need to multiply each one of these by an expression to get the denominators to be the same. Well, the one on the right, x plus 4, is missing an x. So we're going to multiply it by x over x. Or, yeah, so the one on the left is missing an x, so the one on the right is missing an x plus 4. So we're going to multiply it by x plus 4 over x plus 4. Now, the numerator is still 5 over x plus 4. Now, our denominator fractions both have the same denominator, x times x plus 4 and x times x plus 4. So the denominators are now the same. The numerators, x times 1 is x. 2 times x plus 4, well, 2 times x is 2x, and 2 times 4 is 8. Questions on this so far? Now that the denominators of the denominator are the same, we can add those together. So we're going to have x plus 2x plus 8 over x times x plus 4. what we're saying is we have 5 over x plus 4 over, well, x plus 2x is 3x plus 8 over x times x plus 4. Any questions on how we got to this point here? Okay. All right, so we have these two here. Yes, we're good with how we got it to this here. Now, if there had been two fractions on top, we would have had to add or subtract those together. Same with the bottom. We try to get the top and bottom to be exactly one fraction. But what are fractions really? We're just what? The numerator divided by the denominator. So really what this is saying is that I have 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. But we don't really divide fractions. We keep, change, flip. Well, x plus 4 and x plus 4 will cancel each other out. And what we have left is 5x over 3x plus 8, and that is it. You'll be able to write this next part above it. Questions on this here? Method 2. We're going to do the method 2 with the same problem. Method 2 is a little bit different. In method 2, I want to find what the least common multiple, or we can call least common denominator of this here. If we're going to make all of the denominators, all of them be the same, so looking at these three denominators of each fraction, what will all three of them need? Well, they all have how many x plus 4s? 1. So they all have an x plus 4, yes? What else do they have? X. And really what we're doing is something very simple. Looking at the numerator, if I multiplied the top fraction, put that way too close, by x plus 4, if I multiply this top fraction by x plus 4, what's going to happen to it? Because we multiply with the top, yes? So what's going to happen to this x plus 4 at the bottom? If I multiplied x plus 4 with this fraction here, what's going to happen to that one? Cancel out, yes? So essentially least common denominator. We're looking for what I can multiply top and bottom to get these fractions to simplify. Now we know for those two, we need an x plus 4. Is there anything else we need? An x. Because the x will simplify that fraction there, yes? Okay. Any questions on this so far? Okay. Now we're going to multiply everything on top and bottom by x times x plus 4. I'm going to write this out, but most likely once we get used to seeing this, we'll just start canceling things out as we go. So for the first one, we're going to multiply by x times x plus 4. Multiply with the numerator, so we'd have 5x times x plus 4 over x plus 4. Okay. I think we feel comfortable saying that. Now we'd also do it with the denominator. We're going to multiply it with both. The 1 and 2, x times x plus 4 times 1 is just going to be x times x plus 4 over x plus 4 plus 2 times this is going to be 2x times x plus 4 over x. So this makes sense of what we just did. We found the least common multiple, least common denominator. What term we can multiply the top and bottom of this fraction by to get the individual fractions denominators to simplify. As we look at the top one, x plus 4 and x plus 4 will cancel, leaving us with 5x on top, yes? The denominator, the x plus 4 and x plus 4 will cancel, leaving us with x for that first one. Plus, here, the x and x will cancel, leaving us with 2 times x plus 4, yes? Questions on this so far? Now we do need to simplify. X, because we can distribute the 2. 2 times x is 3 plus 2x. 2 times 4 is 8. And x plus 2x is? Which of the two methods do y'all like better? This one's a lot nicer, isn't it? And there's a reason I said method 1 will do it once, and that's never going to think of that one again. Because it still works, but it's a lot more work to put the fractions together, then divide, multiply. So many more steps where if we find out what the least common denominator is, what we can multiply the top and bottom to get the individual fractions to simplify, it'll do the exact same thing. Questions on this here? I have a feeling we want to do this one by method 2, yes? Yeah. Same thing. So, looking at the 3 fractions in this complex fraction, what is one thing we need to multiply the top and bottom by to get the fractions to simplify? X minus 2. So we'll have to multiply it on top and bottom. Then we also need an x, yes? Now we do need this to be the least common multiple. Because in any of the 3, x minus 2, in each fraction, individual fraction shows up how many times? In the top. In each one of the fractions in the top, how many times does x minus 2 show up in the bottom? Once, yes? In the denominator, between those 2 fractions, how many times does it show up in the bottom of the fraction? Once, only once, right? So we only need it once. If it had been, say, multiplied by x minus 2, on top we have 2 of them, we would need it twice across all of them, because it shows up twice. Now, this seems like it's not as big of a deal or as important, because again, if it's not needed, we don't need to go above. Because x by itself only shows up once. In any of the denominators, it only shows up once. We only need it once. Yes? Yes. So, we need to make sure we keep it there. Now, something that we can do is, so don't write this down, because I want to show you an example of something. Say, I just said x minus 2. We already know, and we've already stated that that's not all we need to multiply the top and bottom by, yes? So if I go on and just multiply this, so I have 6 times x minus 2 over x minus 2. In the denominator, 1 times x minus 2 is just going to be x minus 2 over x minus 2. Plus, then we'd have 3 times x minus 2 over x. Now, looking at all these here, on top, we know that these 2 will, here, these 2 cancel. Will anything cancel here? No. So, I'm missing something, yes? Because if you're not sure if you have everything, do what you know for sure and go through and simplify. Here, okay, I'm missing an x. So that means I need an x over x here. And we can multiply back through. That just means that this will be times x times x. Okay, now they cancel out, everything's gone. Does this make sense? And especially when we get to solving where we've got to multiply through, if we add more, it'll make it harder. Because what we get left with here is 6 times x, which is 6x. And y'all can start continuing following along.
Oh.
Yeah.
Oh, you already distributed all that. Okay.
I'll pause for a second and let y'all catch up. So we got 6x on top. The first fraction is just going to be x, because that's the only thing left, plus 3 times x minus 2. So we'd have 6x over x plus, because 3 times x is 3x. 3 times negative 2 is negative 6, which gets us 6x over 4x minus 6. Yes? Now, up to this point, we've been able to just say we're done, circle it. But it is good to make sure there's no greatest common factor on top and bottom, even if there's nothing in common on top and bottom. If we look at the denominator, is there a greatest common factor between 4x and 6? Well, just 2, because 2 will go into both 4 and 6. So we can factor it out, but you'll leave us with 2x minus 3. Because in some problems that won't mean anything, because if we had 7x on top, 7 and 2 don't reduce, so we can leave it as that there. But unfortunately, 6 and 2 do have a common factor of, which will make the 6x into 3x, and the 2 is now 1. So this here is our final answer. I can scroll it up just a little bit. No. Yeah. Out of everything we could be doing, like method 1, I'm not going to require y'all to do this by method 1 or method 2. You can pick which one you want. I have a feeling you're going to pick method 2 every time. Yeah. Mm-hmm. Yes. Mm-hmm. Questions on this here? We ready to look at the next one? Now here, do we have any variables in the bottom of the fractions? Well, no. But we're looking at 6, 3, 5, and 10, yes?
Yeah.
So we need to know what is the first number we can turn 6, 3, 5, and 10 into? Well, what can we turn, first number we can turn 6 and 3 into? 6. Yeah, because 6 and 3, we can turn them both into 6, yes? How about 5 and 10? Up, because we can turn 5 into 10. So really the two numbers we're really looking at is what is the first number we can turn 6 and 10 into? So math, number, least common multiple of 6, comma, 10 is 30. So what are we going to multiply top and bottom by? 30 over 30. So we'll multiply each of these fractions by 30. So we'd have 30x over 6 minus 30x over 3. And the denominator will do the same thing. 30 times x is going to be 30x over 5 minus 30 times 7 is going to be, well, what's 3 times 7? Out of 0.
Can we just flip the top ones?
So looking at the top two, 30 divided by 6 is
5.
x minus,
No, it's not. 4 times 5. 6 times 30. The number's 30, Lily. I thought you said 20.
yeah, 30 divided by 3 is
Oh, exactly.
10x. The denominator, 30 divided by 5 is 6x minus 21.
I was like, what? What 20 are you talking about?
The numerator, 5x minus 10x is negative 5x. Can we combine 6x and negative 21? Does 6x and 21 have a greatest common factor? 3. We can factor it out, which will leave us with 3 times 2x minus 7. Well, can we reduce 5 over 3? No.
Really do. I love that show.
What did you say?
But that's he not it. It is so
Call
funny.
Dr. Sturgis something.
I know what you're talking about. I watched this one the other day, but I don't remember what it was. They called him a. He gave them a bunch of. There's he was No. Like in the front of the class. I was like, we were back there.
Yes, you guys are naked.
Questions on this here? You can leave it, correct? Questions on these here? How do we feel about these so far?
I like this one for the rest. So what else do you have for this off? Is there a catch somewhere?
Here we go.
Oh gosh. I just say something.
Now, let's look at this one here. Now, looking at the numerator and denominator, there's only 2 fractions. One in the top, one in the bottom. Now, for us to be able to simplify the 2 fractions out, what do we need to multiply by?
2x plus 3.
Over 2x plus 3. And that's the only thing we need to multiply through, because the 2 fractions that are in this fraction on top and bottom only have a denominator of 2x plus 3. So there's only one thing we have to multiply the whole thing by. So we're going to multiply each one of these terms by this here. So we're going to have x times 2x plus 3 minus 4 times 2x plus 3 plus 9 times 2x plus 3 over 2x plus 3. All over, we'll do the same thing in the bottom of the fraction. So we'll have x times 2x plus 3 plus 3 times 2x plus 3 minus 5 times 2x plus 3 over 2x plus 3.
It just now clicked for me, but I For some reason, this made me understand.
Sometimes I would say, quote unquote, harder problems
Yeah.
make the logic or the reasoning behind it make more sense.
Yeah, because I can actually see it.
Mhm. Now the nice thing is that these 2x plus 3's and these 2x plus 3's will cancel out.
So,
Let's go on and distribute this here. 2x times x is 2x squared. X times 3 is plus 3x. Negative 4 times 2x is negative 8x. Negative 4 times 3 is negative 12, and then we have plus 9, because our 9 is left over from the fraction. Now we do the same thing in the denominator. X times 2x is 2x squared. X times 3 is plus 3x. 3 times 2x is plus 6x. And 3 times 3 is plus 9. And then we have the minus 5. Okay. Questions on this here so far? Now we can combine like terms. So we'll still have 2x squared on top. 3x minus 8x is negative 5x. Negative 12 plus 9 is negative 3.
I think I did that one too.
The denominator will have 2x squared. 3x plus 6x is plus 9x. 9 minus 5 is plus 4.
I feel smart now.
Oh man, I was canceling.
So we can't cancel them out quite yet because we do need a factor. Now both of these will factor. So the first one, since the third term is negative, our signs are opposite. One's positive, one's negative. Well, factors of x squared are x and x. Then we'll have 2 and 1. Do we want to put the 2 in the first set or the second set? First, so we'll do 2 and 1. Factors of 3 are 1 and. And if we check this here, 2x times negative 3 is negative 6x. 1 times x is plus x, which gives us negative 5x, which is what we wanted, yes? Okay. The denominator, since the third term's positive, the signs are the same and they match the sign of the middle term, which will be plus and plus. Factors 2x squared will have x and then 2 and 1, yes? Well, since they're both plus, it really doesn't matter where we put the 2 and 1, so we'll just put in the first one. Factors of 4 are 1 and 4 or 2 and 2. Which one do we think we'll use? Because if we're going to have something be the same, we're either going to need one of the denominators to be x minus 3, which isn't possible because both signs are positive. So we'll need possibly one of them to be 2x plus x plus 4. And if we check this here, 2x times 4 is 8x. 1 times x is plus x, which is the middle term we wanted. Yes? So that tells us what? These cancel out, leaving us with x minus 3 over x plus 4. Questions on this here? Not too bad. Any other questions on any of these here? So looking at the rest of the ones on the note sheet, we'll do one more together, and then I will give you the rest of the time to work on the assignment. So go on and look at the rest of them that we have, and pick one, and we'll do it together. Yeah. So we'll do one more. So we can look at that one.
This one is.
Yeah.
Okay. Oh my gosh.
It
Can you
looks harder
just
than I
cancel
bet.
it all out?
So we could if the signs were the same on top and bottom. Even if we could, since the, yeah.
Yeah. We can just
Yeah.
draw the line.
Okay, I quit.
Now, in all of them, x plus 1 does show up one time in each one, yes? Because we have it once in either of the denominators. So we're going to multiply the whole thing by x plus 1 and x minus 1. Now the first one, when we distribute this through, we'll have x minus 1 times x plus 1 times x minus 1 over x plus 1. But we do know that this x plus 1 and x plus 1 will cancel out. In the second one, we have x plus 1 times x plus 1 times x minus 1 over x minus 1. Well, we know the x minus 1 and x minus 1 will cancel out. Now in the denominator, we'll have x minus 1 times x plus 1 times x minus 1 over x plus 1. And here we know the x plus 1 and x plus 1 will cancel out. Plus. And the last one, we have x plus 1 times x minus 1 times x plus 1 over x minus 1, and those will so there are a lot of terms, but we're just multiplying it by the numerator, multiplying it out. So in the first one, all we're left with is x minus 1 times x minus 1 minus. The other one on top is x plus 1
Are you serious?
times x plus 1.
You can just cancel it out. Right? Yeah, but after some serious thought and brain damage. And brain damage. Don't
A
tell
little
me
bit dramatic.
don't tell me your brain is not a good thought right now. Get on. Everything cancels out.
Since the signs are different on top and bottom, we can't just cross it.
Oh, silly Willie.
Looks like you
Unless we
should.
would have done that a long time.
How do we do it?
That's what I told him at the beginning, and he was like, no.
We're going to multiply each one of these out and then combine like terms.
I'm okay.
And then cross them.
You would be dead. Be real.
Now, x minus 1 times x minus 1. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. X times x is x squared. X times 1 is plus x. Negative 1 times x is plus x. And 1 times 1 is plus 1. Okay.
Oh, I was looking up here and I was like, man, Ramsey, that's good.
Now, the next one we're doing is x minus 1 times x minus 1, yes? Haven't we already done that?
Yeah.
So it's going to be x squared minus
He's
x.
trying to break in. You just add him.
I don't think
I Yeah,
Denny is very concerned about it.
Def should have.
I don't think so.
Because I'm
All right, guys. Now we can combine like terms. So we combine the x and so for the first one, negative x minus x gives us a negative 2x. And for the second one, x plus x is 2x. Now for the denominator, we can go on and drop the parentheses. The numerator, for the first one, we can just go on and drop the parentheses. But for the second one, we do need to distribute that negative through it. So our positive x is now negative x squared. Our positive 2x is now negative 2x, and our positive 1 is now negative 1. Looking at the numerator, x squared minus x squared is what? X squared minus x squared is 0. Negative 2x minus 2x is negative 4x. And 1 minus 1 is 0. So the numerator is negative 4x. The denominator, x squared plus x squared is 2x squared. Negative 2x plus 2x is 0. And 1 plus 1 is there's only one last thing. Is there a number that will go into the two denominators? 2. And if we simplify that out, we get negative 2x over x squared plus 1. The only thing that would probably been more infuriating if it came out to be 4. That's it. Now,
I would rather take the 0
Yeah,
than to do that.
there's no way my brain's gonna see a problem like that and comprehend that at all. There's no way.
I would be calculating my brain.
I'm not even doing that. It's not before.
Oh, there's only 4. Wait, is it like
there's no multiple parts.
there was?
39, 40, 42, and 44. There are exactly 4 problems.
Okay, I was scared it'd be like 39A, B, C.
No.
That's what Kendall would do.